Go. All right, hello everybody. We are Better Butter Technologies, and this is our presentation on margarine production. My name is Asif Rahaman. I'll be doing the introduction, the economic analysis, and the conclusions. I'm joined by Armando Zavala, who will be doing the description of the unit operations, the process flow diagram, plus the calculations, and the description of the unit operations. I'm also joined by Nate Stein. He'll be doing the QFD and the ethical considerations. So the name of our company is Better Butter Technologies, and this better butter that we're talking about is margarine. Margarine is produced using vegetable oils. Some processes use one type of oil, others use a combination of different oils, as we do in our process, which you'll see later. Historically, margarine was used in times when dairy was scarce. Margarine also provides a heap of health benefits as it has significantly lower saturated fats and contains no cholesterol because it's made with vegetable oil. The cost of margarine is also traditionally much cheaper than butter. At Better Butter Technologies, our goal is to create a healthier, cheaper, and easier to use alternatives to dairy products. The company will initially produce margarine, and as it grows, we'll start diving into producing other dairy and non-dairy products. We're based in Atlanta, Georgia. We will produce over 100,000 metric tons of margarine each year, and the margarine will be sold at a fixed price of $4 per kilogram.
All right, our quality function deployment introduction. We're going to prioritize factors such as spreadability, texture, and taste. We want our product to promote health and to be cheap, cost effective. And the consumer also wants a long shelf life and recyclable packaging. Here's our QFD chart. As you can see, the customer needs able to be spread, good texture, remains solid at room temperature, cost effective, long shelf life, recyclable packaging, pleasurable taste, and to promote health. Our main objectives are to be cost efficient, satisfy the consumer, and benefit their health and well-being. The constraints we're working with here, the weight of the packaged margarine cannot exceed 1.814 kilograms. The price of one stick cannot exceed $4 per kilogram. We must produce at least 100,000 metric tons per year. It must have a 9-week shelf life, and it can't melt at 20 degrees Celsius.
So the first step in this long process is to extract the oils from the seeds. The seeds we are using, well, the process starts with the low pressure press, which extracts the oil from the seeds we're using, which are soybeans and the palm seed, palm seeds. The grains are introduced into the low pressure press at about 40 degrees Celsius, and and they are processed by the press, and oil is extracted. Solid waste is also a byproduct of this step, but that is stored in tanks and storage tanks to later be sold either to farmers or to animal feed manufacturers. The oil that has been extracted from both soybean and the palm seed are then passed through a series of filters. The oil individually passes through the filters in order to refine the oil into a more clear and yellowish liquid. This also eliminates any possible solids getting through that can cause any defects in the margarine, the final product. The refined vegetables are then pumped into mixing tank A, where they are stirred until they are fully homogenized. And once the oils are homogenized, they are pumped into mixing tank C. The oils themselves are composed of fatty acids, primarily palmitic acid, stearic acid, oleic acid, linoleic acid, and a trace amount of myristic acid. In a different tank, mixed tank B, fat-soluble additives are added and mixed together at around 55 degrees Celsius. The fat-soluble additives include emulsifiers like lecithin antioxidants like BHA or butylated hydroxyanazole and BHT, which is butylated hydroxytoluene, toluene, sorry, and our main coloring agent, which is beta carotene, which gives the margarine its distinct yellowish tint. Once the fat soluble additives are homogenized, they are pumped into the mixing tank C, which already contains the refined oils, and these two are stirred and mixed at 55 degrees Celsius in order to remain liquid. And once the new mixture of fatty acids and slash oils and these fat soluble additives are mixed well enough, they are pumped into mixing tank E. In a fourth mixing tank, initial mixing tank, water is pumped into it along with salt and other materials such as preservatives, which are crucial to our product in order to maintain a long shelf life. Our main preservatives are citric acid and sodium benzoate. Diacetyl is also added in order to improve the butter flavoring of the margarine. And these components are mixed until they are homogenized and then pumped into tank E, where the mix of oil and additives has already been mixed or pumped into. And this final solution is mixed well enough until it itself is homogenized. And this solution is then passed through a scraped surface heat exchanger, which lowers the temperature of the product to about 10 degrees Celsius for a minute. And once the product is cold enough, it is passed into a crystallizer, which treats the margarine rotating pins as it passes through. And the product remains in the crystallizer in the first crystallizer for about 20 minutes before passing on to another heat exchanger. And this heat exchanger is set at a lower temperature in order to lower the temperature of the product. This heat exchanger is set at -4 degrees Celsius. And after the heat exchanger, this product is sent through a second and final crystallizer that treats the margarine for another 5 minutes. The crystallizer's main purpose is to reach the nucleation point of the triglycerides that are found within the fatty acids. The final product, after it has been crystallized for a second time, is margarine, and this product is sent through a small square tube that feeds into a packaging machine in order to get that brick shape that we are familiar with. So here we can see the entirety of the process and the process flow diagram. We have the different mixing tanks that all come together to a final mixing tank, which then undergoes the heat exchanger and the crystallizer twice. And here are our material balance calculations. They are the composition of each stream determined by percent of mass of the stream itself. So the low pressure press, the reason it is called a low pressure press is because the low temperature inside creates a low pressure. Sorry. Each press is worth about $10,500, which equates to $21,000 when considering both. And each one extracts oil from its respective seed. We have 2 filtration units, which each filter an oil extracted from a different seed. Each filtration unit costs about $10,000, which totals about $20,000. And this is it's not the most important step, but it is pretty important in order to get homogeneous margarine down the line that is high in quality. The storage tanks are not super crucial and can be pretty much replaced by anything that stores a solid. It's just used for the solid seed material that we dispose of or that we sell, or that we can sell to animal feed manufacturers. We have 5 different stirring tanks, all of them mixing at 55 degrees Celsius, and then we have 2 crystallizers. Each of them has a rotor shaft inside that is fitted with stripper blades, which press against the inner surface at high rotation speeds. And this high pressure mixed with the low temperature induces nucleation and crystallization of the product. Each crystallizer is worth about $40,000, which sums up to about $85,000.
All right, so in our economic analysis, the inside battery limit cost includes the major equipment such as the crystallizers, the low pressure presses that Armando just mentioned, added with the bulk materials such as PVC pipes and whatnot. That totals to over $960,000. That the inside battery limit costs are added to the OSBL, which was found as 40% of the ISBL. We estimated that. And the contingency, all of that is added together to find the total capital cost of our process, which is over $1.6 million. The variable cost of production, this takes into account all of the raw materials going into our process, salt, water, the various vegetable oils that we're using to make our margarine. And we also took into account the waste management and utilities. This totals to around $236,531 per year. The fixed production cost, this is where we take into account our salary, our wages for our employees, and we add to that the utilities, the taxes, the corporate charges, the labor costs, and that comes out to just over $1.3 million per year. The cash cost of production is found by summing the variable cost of production and the fixed cost of production. Our CCOP is $1.5 million per year. Our projected payback period was calculated by finding the total amount of margarine sold per year, which is $4 million per year, subtracted from our cash cost of production, which gives us our total gross profit of over $2.4 million per year. And the simple payback time was calculated as 0.68 years, which is roughly 8 months. The ACC annualized capital cost was calculated using this equation, and that came out to over $2.7 million per year. The total cost of production we found to be $4.2 million. And from the second year onwards, the company will make a profit of $2.4 million per year. And if Better Butter Technologies continues on this path for the next 10 years, the company is expected to make over $18 million in profit.
All right, the ethical considerations we took into account. Firstly, the palm oil industry has an infamously negative impact on rainforests, specifically in Malaysia and Indonesia. So we want to make sure that our palm oil comes from a supplier that supports sustainability. Also, the choice of recyclable or non-recyclable packaging can have a global impact. Obviously, using non-recyclable packaging has a negative impact, but if we choose to use biodegradable or recyclable materials, we can counteract that negative. Margarine has a higher PCOP impact than butter. This is photochemical ozone creation potential. Basically, the higher the PCOP score, the worse the production is for the ozone layer. However, if we stray away from the use of hexane in oil extraction, we can create a more environmentally friendly method.
All right, so in conclusion, we believe that with all the evidence presented, it's clear to see that our company has a bright future. Our payback period is very short, only around 8 months. Our annual profits are over $2 million. We've taken the necessary ethical and safety considerations to ensure that our process is safe and will continue to be safe in the future. We're based in Atlanta, Georgia, so there are numerous opportunities for future expansion. And we're based in Georgia, so that means that we can source our crops locally, and we won't have to rely on international sourcing for our vegetable oils and whatnot. And we look forward to taking the next steps and getting Better Butter Technologies margarine in your refrigerator in the not too distant future. Thank you.
Thank you.
Thank you.